Hi, welcome to our webinar today. So today we're going to be talking about specifically about artifacts. So the kind of general plan here is that I'll go over a little bit of what are artifacts, and then a little bit of the basic theory, some use cases, and then finally at the end, what we'll do is that we'll go into the actual web UI, and you can see a little bit what that looks like, where that shows up, and all that stuff. So let's just get started right away. So we have some slides for this. All right. Why artifacts, and to an extended perspective, what are artifacts? So generally speaking, kind of the generic term to explain what artifacts are is externally generated data. So that can be files, as well as just data that's not necessarily specifically files, but anything that's generated outside of LimaCharlie. As you probably know, LimaCharlie agent events, as they come in, are very well structured JSON, but sometimes we need to be able to take external things and bring them into LimaCharlie land, and we want to try to make sense of it, as well as be able to operate on it, right? That's kind of the key. So the common use cases would be, for example, Windows event logs. So Windows event log files on Windows are files on disk where Windows does its logging, and LimaCharlie does not generate those logs itself, but sometimes there's things that we very specifically want out of them, and so we want the ability to go and get those and bring them into LimaCharlie. But as you can see here, so syslogs, but also PCAPS, so network traffic, can be in there. Also, some kind of more esoteric file formats. So prefetch files, PEs, full memory dumps, generic formats as well, JSON, CSV, all that stuff. As we bring them in to LimaCharlie land, what happens to them is a couple of different things. And we'll go through the specific kind of process, but at a high level, well, we're going to retain them. That's kind of the obvious one. So we will retain the original. And we'll do that for however long you request. So on per artifact, you're able to say how long you want to retain that given artifact. We will detect. So as you will see, we'll have the ability to take those artifacts. Let's say, for example, a Windows event log, and in the same way as you can write DNR rules, so detection and response rules, in LimaCharlie, which is kind of the global engine in LimaCharlie to do all things that are rules. You'll be able to write a rule that operates over Windows event logs. So even though they're not generated intrinsically by LimaCharlie, they're external, you're still going to be able to write detection and response rules there. Finally, well, not finally, but we will also be able to explode things. So again, we'll get into use cases that are very specific to that, but it's kind of the concept of taking sometimes one of those artifacts and being able to explode it, meaning kind of generate other artifacts from it, and then re-ingest those and then parse those and kind of do the whole thing. And finally, so the search is that depending on the artifact type, what we're going to do is we're going to extract indicators of compromise. So in the same way that we do extraction of IOCs in LimaCharlie events, so from the agent, we'll do the same from artifacts, and that's going to allow you to be able to say in the LimaCharlie search, instead of looking specifically, let's say, for an IP inside of LimaCharlie agent telemetry, you're going to be able to say, actually, I want to look at it for artifacts that match this, and we'll be able to give you similar results. So that's kind of at a high level what artifact will allow you to do. So Let's just go into a bit more details, right? So the ingest phase. So these are the phases of ingestion in LimaCharlie for artifacts. So the ingest, the important part here, and I'll zoom this a little bit, I think, or maybe not, whatever. So the ingest phase is where you send us the data. It's very simple. And there's a couple of different ways that you can do this. Underlying all of those ways, there's really one way, which is a REST API. So at the end of the day, there's a REST API. So if you have access to curl or like anything that can do a web request, you have the option to be able to send artifacts to LimaCharlie. So that means you're not required to have some kind of really complex CLI or sometimes an agent installed or any of those things. At the end of the day, you can send one-off artifacts to LimaCharlie. And that API works on ingest API keys. So it's a different set of API keys that only allow you to ingest data. So they're, from a security perspective, there's less to worry about. The other methods are automated through the sensors. So LimaCharlie agent, for example, is able to monitor for changes or existence or any of those things, files on the host where the agent resides. So in the Windows event log example, and again, we'll step through that example, you might want to point to a Windows event log, and you can tell LimaCharlie, like when there's changes, like over time, I want to just grab a copy of this and ingest it as an artifact. You will also be able to do this type of ingestion specifically with PCAPS with LimaCharlie Net, which is a new service that we're rolling out right now that allows you to do device level network microsegmentation, monitoring, control. And so you're going to be able to just say, for example, I want to collect a PCAP of port 80 and have this automatically ingested as artifacts into LimaCharlie. So using sensors. Finally is the CLI tool. And the CLI tool is our Python CLI/SDK that's available publicly. And with it, there's a command. So you can say LimaCharlie artifact upload, and it will kind of automate the same aspects of uploading using the REST API, but just through a command line. So it's a little bit more convenient. And if you want to automate things in boxes like ingestion, then it tends to be kind of the easiest way to do that. Once the artifact data, so let's say it's a Windows event log, right, or a PCAP, is received by LimaCharlie, the first thing that we're going to do internally is that we're going to normalize it to JSON. So, there's some context here when we use normalize and JSON. There's kind of a little bit of a fuzzy area here. So, what we're doing is not strictly normalizing to some gigantic, unified model of all the things in the world, but rather what we're doing is that we're saying, look, I know that this is, for example, a Windows event log, and I understand the parts of it. I'm going to take, the binary format that this is in, and I'll convert that into a JSON format. So JSON, which makes it both machine readable as well as human readable. So it's kind of a general context, a general format that we can use. And that's what's going to allow us to do all the cool stuff after. So we generate a mirror file that's in JSON. So we always keep the original, and then we create a mirror file, which is the JSON representation of the original. Once that's done, we move to the detect stage, where what we do is that we take this JSON representation and we take all of the DNR engine rules that you've specified, and we apply them onto that artifact. So we'll kind of do it in two different ways. So one is on the JSON itself, right? So let's say it's a Windows event log. Maybe what we'll do is we'll take this, maybe if you've enabled Sigma rules, they contain a bunch of DNR rules that apply to Windows event logs. That's automatically going to match, and then it's going to, generate alerts, generate detections, just normal LimaCharlie stuff. The other one is that we also generate a meta event, which is an artifact event type. And that will essentially just tell you, hey, by the way, I've ingested a new artifact of this type from this box, kind of the basic metadata about it. And that means that you can create DNR rules, not just on the content of the artifact that came in, but you can also automate things based on the fact that an artifact came in from a specific box or something like that. You can create rules to automate flows around that. Finally is the retain step. So essentially what we're doing there is we're just taking the original, the JSON, and then we are retaining it for the number of days that you specified. So at ingest time through the REST API, the CLI, or the rules that you set up around your agent, you're always going to be able to set a number of days of retention. So maybe it's very bulky data you want to retain for a short period of time, so you could say retain it for 3 days, or it's pretty efficient logs that are really, really important for audits in the future, and you want to say I want to retain it for a full year. You can do that right there, and that's generally the kind of the once over process. But the part that's really interesting comes after. So what we're kind of, the overlay that we are adding here is the explode step that I mentioned earlier. So when the initial artifact came in, it went to the DNR engine, and I mentioned that you can have a rule that says, hey, if a artifact of type PCAP gets ingested, and maybe from a specific box or with tags or any of those things, then I want to do something. Well, those that have used LimaCharlie for a while kind of know, the whole Lego blocks kind of architecture that we have. We really love to create features that can kind of really feed off of each other and be much bigger than the sum of their parts. So you can create a DNR rule that would, for example, say that when a PCAP comes in, I want to send that PCAP to one of the LimaCharlie services. So LimaCharlie services is a public framework, open source framework, that you can create services that kind of embed more deeply into LimaCharlie while still living outside of the LimaCharlie cloud. It's a really cool thing, and we produce a ton of those services ourselves. That's what we use. And so you could have a rule that would, say, okay, a PCAP came in, I'm going to get it processed by this service. Let's say, for example, the Zeek service. The Zeek service takes that PCAP and is able to explode it, right? It runs it through rules, through like its default pipeline, produces a bunch of log files. Well, all these log files can then be re-ingested into LimaCharlie artifacts. And so the service knows how to do that very, very easily, transparently for you. So what you end up with is the ability to say, okay, I'm going to take PCAPs in, and by the way, I want to have those processed by Zeek. And by the way, LimaCharlie understands what a Zeek log is able to normalize it to JSON. So now you can write DNR rules that operate on the Zeek format, right? So like Zeek will kind of summarize a lot of the information or extract a lot of interesting bits. So you can create rules that are based on those directly. So there's a feedback loop in there that's possible. Let's look at a couple of use cases. So the first one, honestly, is the most common one on Windows. So Windows event logs. So on the ingest part, so by the way, I'll go over a little bit, kind of narrate, what that process looks like, and then I will show you the relevant configurations that resulted in this being possible. So that can give you a bit of an idea. So we've configured our sensors to collect Windows event logs automatically. So That's a very quick rule that you can say, I want this log and this log automatically come in. You hit save, and a short while after, they kind of start rolling in. LimaCharlie takes care of monitoring when there's changes, every given amount of time, all that stuff. The Windows event log comes in. LimaCharlie Artifacts Ingestion understands Windows event logs. So although it's a binary format, it's able to parses it into JSON. And that's that mirror file. It goes through the detection process. So an organization can, for example, subscribe to the Sigma service. So Sigma service is free, and it applies a bunch of rules that are provided by the community, the Sigma open source project, if you want to look it up. And there are hundreds of rules that kind of cover the whole spectrum of different attacks and anomalies and all that stuff. So if you subscribe to Sigma, it's going to create in your organization a whole bunch of rules that specifically know to target Windows event logs. And that will automatically apply to the Windows event logs coming in as artifacts. So with that one click, you kind of get all those to apply to your artifacts. Any of the detections that happen during that stage will go to just your normal detection feed in LimaCharlie, and eventually into another service that we're launching called Comms that will allow you to kind of get more context around your detections. And that's really kind of the operational consoles for folks doing the security day to day instead of the managing the infrastructure around the security. So that's the detect step. And then in our case, we could say, for example, okay, we're going to retain the Windows event logs for 6 months because we feel that that's a good amount of time. So what does that look like? So here's the two relevant bits. So the top screenshot here is a rule for, an artifact ingestion rule. So where we're saying, hey, I want to collect all from all Windows boxes for the default of 30 days here. Any tags, so I'm not specifying any specific tags. I want to grab the, sorry, it's a little bit crunched up here, but you have the security and system event logs. Create this rule, hit save. That's all you have to do. The bottom one here is just a view of the Sigma add-on that you can subscribe to, so the service. So you can go just click to enable it, and once it's enabled, you won't see the rules being created in your DNR rules page, but they're just hidden essentially for you, but they all get created in the background. So let's go to another example. So example using LCnet. So on LCnet, it's a little bit different, right? Because LCnet is essentially the ability through a VPN to monitor at the device level and apply various different policies. So in this case, what we're saying is we're going to ingest PCAPS automatically from LCnet client, and we're essentially going to create a policy that says capture, UDP 53, TCP 80, and TCP 443. So that's if you've done network analysis, that's a BPF filter. It's just a way of expressing what you want from the network. You could also say, everything. Just give me everything you've got. And once you create that policy, they will start the PCAPS will just start streaming in to your artifact. The convert phase, really straightforward. Again, LimaCharlie understands exactly what the PCAP is. It's going to convert it to JSON, but what it's going to do is that it's going to take the various layers of the packet that it understands and convert those to JSON. So, if it's like random bytes that are in HTTPS session, it's not going to be able to interpret those. But it'll give you all the layers of the packet. So in the detect phase, it means that right there, automatically, if you wanted to write some DNR rules that look for specific anomalies, in various headers of the low-level traffic, you could do that right there because it gets parsed to JSON. But really, the interesting bit, as I kind of mentioned a little bit earlier, is we're going to create a rule that says if I see a PCAP, I'm going to send it to Zeek. Oh, pardon my typo here. So I'll send it to Zeek, and from there, I know that the Zeek logs will get generated and will get re-ingested as artifacts, and we'll get to that. So the retain step, again, super straightforward, except in this case, the interesting bit is, we're potentially taking in a lot of PCAPs. It's a lot of data. So what we're going to do is maybe I'll set a lower time of retention on the PCAP. So I will say, you know what, keep this PCAPs coming in for 1 month. So I know that I can have 1 month of full capture on all my devices. But for the Zeek, the rule where we say, send this to Zeek, we're going to ask Zeek to retain its logs for 6 months, because we know Zeek logs are much smaller. They kind of go straight to, the interesting bits of information. So we're going to have those 2 stages. So we're not ending up, retaining PCAPs for a whole year for kind of no reason. We're optimizing the way we do our storage. And the explode part is, really what I've been, peppering through this, which is there's a rule, sees the PCAP coming in, a request gets sent to the Zeek service, and Zeek does its thing, generates a bunch of log files, ships them back to the artifact, and the cycle, goes over again, except this time you can create detection rules on the Zeek logs and all that stuff. So what does that look like? So here's the 2 components. So the first one on the, let's start with the one on the right. So on the right, what you're seeing is a LCnet policy. So that's just a small policy, YAML blob that you can apply. And this is saying, we want to capture this BPF filter, so TCP port 443, TCP port 80, and UDP port 53. So in this case, I'm saying I want to retain it for 3 days. And, just for added kind of context a little bit here. So the times here is saying, hey, by the way, maybe this is the mobile phone for, my sales people that are, going across the country. So I only want to do this from Monday to Friday, 8 to 6 Pacific time. So the LCnet policies have a ton of ways that you can customize that stuff. So essentially during the workday, I'm going to capture HTTPS, HTTP, and DNS with this. On the left side, what you're seeing is the what allows us to do the explode step, right? So this is a DNR rule where we say at the top, hey, I'm looking for ingest events, and really I'm targeting, so it's ingest events of type artifact event. So there's other types of lifecycle events in artifact event. And the filter I really want is the artifact type PCAP. I want all the PCAPs. I could drill down and say only PCAP where this header is in the packet and like go into full detail. But here really we're just saying all PCAPs. The response part of that detection and response rule is saying, here's what I want you to do when this happens. I want you to make a service request. So a service request is kind of a first class operation in LimaCharlie. The name of the service is Zeek. And here's the request. Here's what I want you to put in that request. So the action is run on. So the Zeek service supports a couple of actions. Run on very simply says, take this artifact and just run Zeek on it. The retention of 30 days. And the artifact ID, so here's what I'm telling Zeek, here's what artifact do I actually want you to run on? Well, it's the ID that is contained within this metadata event, like this artifact event. So routing log ID, which is the artifact ID of this specific PCAP. So I'm saying run on this one PCAP. So I make that service request, it goes out, and asynchronously all this starts happening. So the final use case, and then what I'll do is I'll show you a little bit through the UI what that looks like, is a little bit different. So in this case, so it's an example for full memory dumps. So the ingestion step is quite different because I kind of take less action for it. So for example, setting kind of a little bit of a scenario, during an incident, an analyst decide to do a full memory dump of a machine. We have a service in LimaCharlie called the dumper service, and you can ask it to dump the memory or the MFT table. And so that analyst says, I think something's going on in memory. We want a forensic memory dump done of that box. So instead of going over to the office, installing stuff, or opening RDP and all that stuff, with like one click, the analyst says, okay, do a full memory dump on this box, go. The service will go and run the full memory dump, and it automates the process as a whole. So it will run the memory dumper, it will take the resulting memory dump and automatically ingest it into artifacts in LimaCharlie. So that can be, like memory dumps can be pretty big, right? They can be up to the size of the physical memory of a box. So, you could easily nowadays have a 16 gigabyte memory dump. So that way you kind of automate that whole process of having it sent to the cloud, and you don't have to go and mess with like plugging in a hard drive or, any of those things. So once the memory dump is done, automatically sent to artifacts in LimaCharlie. And it's sent with a specific type. So when you upload an artifact to LimaCharlie, you can actually give it a hint. You can say, by the way, this is of this type. And the memory dumper does this. It says, by the way, this is a memory dump. At this stage, in the convert stage does not actually is not actually able to parse it into JSON. There's kind of there's a few different aspects to that, but ultimately a memory dump can be very, very, very messy, very, very complex to parse. The things you want to extract will vary a whole lot. So it doesn't make sense to try to create a JSON of a 16 gigabyte, full memory dump. So in this case, the convert stage doesn't really do anything. It's able to go and look at it and say, you know what, I don't know what to do with this, so I'll just pass it along. It's not a failure. On the detect stage, we don't have a JSON format, so we're not going to be able to run a DNR rule today on the JSON representation of it. However, an ingest event will be generated. So we could easily say, maybe as a security organization, we have a capability to take memory dumps, and we have an in-house process that we know how to process memory dumps. And I want to automate this. I don't want to, every time I take a memory dump, go and do clicks and download and all that manual stuff. So what I'll do is I can have a DNR rule that says, hey, by the way, when a memory dump comes in, I want you to to execute this service, to send it to some other service, or to send a webhook, or to do a bunch of these things, so that perhaps like on premises or in the cloud, where I do own my own pipeline to do analysis of memory, full memory dump, I can get that. I can use the APIs, because remember, everything we do is always public API. So I can use the API, go retrieve it from the cloud, where I know it's safe, secure, good retention, fast. I just get it, do my thing on it, and maybe I generate a bunch of executables that I decide to feed back into the artifacts on LimaCharlie, because I know that LimaCharlie artifact system understands Ps, so I can write DNR rules on Ps. So you can see that it's really not like a static flow, right? You really have the ability to do incredible things here. And because a memory dump is really big, maybe I decide to go and only retain it for 3 days, because I make the assumption that I'm going to be taking it out of LimaCharlie at some point to go and do my own parsing. So that's a little bit of a different different example. And so for the configurations there, it's not the greatest mapping, but essentially you can subscribe to the dumper service with one click, and you can make a request to that service where you tell it, the retention, like which endpoint you want to do the dump on, if it's memory or MFT, and then you click request, and that's it. So that is kind of the overview of 3 use cases that we wanted to give you that kind of cover a little bit of the spectrum. What I'll do now is I'll show you a little bit in the web UI. What does that look like when artifacts come in? So here we go. So what I will do is I will go into an org of my own, and I will go look at artifact collection. So showing you artifact collection here, you can see that I have artifact collection rules, as I mentioned, as I showed before in a use case. So this is where you would create those rules. And in this case, I only have 2 Windows event logs, but I also have a rule for Linux. So if I look at Linux, I return for 30 days syslog and off.log. And I specify the .1 value so that I only get it, when it's rotated and it's a clean version every day, I get 1 clean version. So this is a good example of some basic rules to collect common, common things that are useful. And then here's, at the bottom, you get kind of a small preview of here's what artifacts came in recently and their status, right? So I can see that from this, so I know this is actually an LCnet client. I see that I got a PCAP coming in. It will be retained until the 12th, so it's just a couple of days. It's indexed, so meaning LimaCharlie recognized it, generated the JSON, and it went through the DNR rule. So that whole thing went through. I can open it up to have a look if I want. So by default, here what I clicked is to view the parsed version. A PCAP obviously is binary data, so it's not trivial to kind of look at. So here I clicked to view the parsed version, and if I go and I see essentially every packet, and I open up one packet and I can see all the flags, all the bits of metadata that are related to it, right there. And that's what, if you create the DNR rule, this is what it's going to operate against. But I also see the Zeek logs right around the same time. So that's because I have a Zeek rule that I'll show you right after this. So I can see that, here's all the files that my Zeek log generated. So maybe I will go and open up the con. So con.log, which is kind of one of the basic connections log reported by Zeek, and we parse it and we make it into a JSON. So they're kind of log lines while in Zeek format. So it becomes a flat JSON in LimaCharlie. So again, that's if you create DNR rules, you'll be able to apply them at this level. They'll vary by the type of log file that Zeek generates. For example, ssl.log, if I recall, will have a bunch of the certificates that we've seen going over the wire. So that's pretty useful as well. DNS will contain DNS, all that stuff. But I can also download the original and download the parsed from this UI as well. If I go in the DNR rules, and I go all the way to the bottom, you can see I have my Zeek rule that I mentioned earlier. Really straightforward. I just created that, and now I don't have to worry about it. All the PCAPs coming in just go straight in Zeek. So that's kind of at a high level, artifact ingestion. Obviously, there's a ton of other things that you could craft using artifact. If you have specific formats of artifacts, specific types of artifacts, please do get in touch with us and let us know. It's usually fairly easy for us to add a new parser in a day or two kind of thing. And then from that point on, it's just automatically recognized. If you have any feedback about this, about LimaCharlie, about any of the things that we do, so you can head to limacharlie.io/feedback. And if you have any questions, please feel free to put them in a chat. There's a small delay in the webinar, so I'll just wait for a minute or two to see if there's any questions. Also always feel free to reach out directly to us. So you can always go to our community Slack, where we do most of the kind of announcements about the platform, as well as help you if you're an MSSP or an organization. We can create a private channel, have direct discussions with you there. So you can join at slack.limacharlie.io. Very simple. And really excited to see where we keep going with the artifacts. And that's kind of the beauty of the way that we do everything with LimaCharlie, is that the artifact system is actually older than a lot of our other things that we do. But for us to introduce LCnet, which again will make public announcements in the future. The beauty is that introducing LCnet, it really plugs into this ecosystem of capabilities, right? It's not the widget that's got 2 or 3 ways that you can play with it, but rather how to integrate all the things into the types of pipeline that you want, build the type of products that you want. Everything's available there.